Hello. In this video segment, we will together compile a simple program called hello world.c. I'm using a Mac Air laptop with OS X operating system. On Mac OS, compilers are accessible with the terminal application that is visible here at the bottom of my screen. So I open up my terminal window and the window appears. I make it full screen and increase the size of the fonts. I'm now in my home directory. I change directory to the directory I've created for this course and where my hello world.c is located. So I do cd dd1324 codes. Enter. So I want to simply check the C code that we have prepared for you for this class. So to check, I'm using an inline editor called Emacs. You can use gedit or the editor you like the most, like Sublime, TextMate, vi, and so on. So I do Emacs hello underscore world dot c, and here we go. So this is the simple code that we are going to compile. What it does is simply print to display hello world and then exit. I'm using the GCC, that is a free GNU compiler. So we're going to compile our first code. For doing that, we need to do GCC hello underscore world.c. That is the name of our C source code. And then we use the flag -o to indicate what is the name of the executable. So not too much fantasy here. I'm going to call hello world. As plain as that. So you compile it and make our executable here. In order to run it, I just simply do /hello world. And magic. What it does is just simply printing the hello world. I've used /. It means that the dot means that we are executing a program that is in this directory. So dot is this directory, and hello world is the name of the code. So we are basically done, at least when it comes to the compilation of our first code. But before I finish up, I would like to go through the different stages of the compilation. The first stage is the pre-processing phase. So for checking out what is the product of the pre-processing, I use the -E flag and hello world.c, that is the name of our source code. And then I use the symbol greater than that redirects the output of the compiler to a file code. And I called the code after the pre-processing hello world.i. So what it does, the preprocessor, is to simply replace some small code with larger code. We want to look at this hello world.i, and as you can see, we have now a lot of code that was not comprised in the initial hello underscore world.c. I want to see what is the final product of the compilation. So when we go from the source code to assembly code, doing that, I use the flag -S hello world.c, and then I redirect the output to hello world.s. In this case, hello world.s will contain our assembler code. We did it. Let's get a look at hello underscore world.s. And see, this is the assembler. You can see that Emacs recognizes the assembler commands and highlights in color. The important point is that if I give you the assembler code that I generated now, and you're using a Linux machine, with a different processor, you won't be able to run it. Right? So the assembly code that I generated now is machine dependent. One of the last steps of the compilation is the preparation of the machine code that is also called object files. We want to do that, right? Minus, we use the flag minus capital C, hello world dot C, in this case, hello world dot O. So this is the final object before the linking. Right? The linker compiles, takes all these final objects and put it together to make an executable. We could try to open hello world with our Emacs, but it wouldn't work. We just split it up some garbage. Keep in mind that the machine code is basically a collection of instruction in binary. You can just try, just for fun, and see some garbage on our screen. So hello world.o. See, not much we can understand here. Thank you.